Hello viewers, in this video we are going to see how to write Matlab program. So in this section I am going to discuss about 5 different topics: writing a simple program, and writing and calling anonymous function, and writing and calling sub function, and then live script, and then live function. Already we have discussed, so what are the data types, how to create a variable, how to do what you call the expressions using arithmetic operator, and we have studied about relational operator, and then what you call logical operator, and we have controlled we have studied a flow control statement, switch statement, and for and while loop we have already studied. And we have seen different what you call specified functions, different types of functions also we have seen. Now using those what you call details, we are going to write a simple program. So this is the first exercise that we want to do. So the first exercise is find the lower and upper limit of A, B, C and D. So the table column is given. The first column represents A value, second column B, and third is C, and fourth one is D. And from which you have to find out what is the minimum value of A and B, C, D, and maximum value of A, B, C, D you have to find out. And then you have to generate NS number of what you call random value between this lower and upper limit of A, B, C, D. So that is the thing that you want to do. So once you are opening your Matlab programming, so this is a window you will see. So actually the current directory E:zoom Matlab. So this is your editor, this is your command area. So in the editor we are going to type the details. I am declaring a variable data. So this data has been copied. Since I cannot copy directly in what you call PowerPoint, I have pasted it in Excel, and again I copied and pasted it into Matlab. So if you are double clicking, your editor window will be maximized. So now the data contain the table values. Now I want to find out what is the lower and upper limit of ABCD. So before that, I want to get how many random values are required. I'm using input function, enter number of samples, right? So next I want to find out, so what is the minimum value or what is the lower limit of ABCD. So for which I'm using minimum function. So once the data is given, so it will give you what is the minimum value of individual column, right? This is to find minimum value. And then next I want to find out maximum value. I'm giving the variable name upper limit, that is equivalent to maximum of data. So this data contain more than one row, then this maximum function will return the maximum of the first column, second column, third column, fourth column, right? Then you will get what is the upper limit. Now this is actually commenting this line. What for? I'm defining this line. So this line is defined to find the maximum limit, and this line to we are using this line to find out the lower limit. Now we know what is the lower limit and upper limit. Now we want to calculate the parameter value, the NS number of parameter value. So what I want to do is I want to generate a random number, and before generating random number, I don't know how many columns are there or how many parameters are there. I am getting the size of this data, that is how many columns are there. So for which I have used a size data comma 2, it will represent the number of columns. So next I am generating a random value for NS rows and NV columns, right? So NS is, we already got the user input. So this is actually predefining or allocating the memory. And PV zeros, we are filling up of my PV variable with the NS row and the NV column with zeros, right? Now I am defining for loop I equal to 1 to NS, P of I comma colon, that is equivalent to LL of 1 comma colon. The meaning of LL of 1 comma colon, so here you are getting the lower limit, only one row you will get, the entire row value will taken here, and R1 of I value. See here you will get NS rows. I represent when I value 1, it will take the first row of random value, and this is actually element wise multiplication. So this element wise multiplication, what it will do is, we'll take upper limit value. So why I have given 1 here? If you are changing 1 by I, the program end up with problem. See, because in UL I'm getting only one row. UL I'm getting only one row. So that's what I have given UL 1 comma colon. So it will retrieve the first row of entire data. And in lower limit, I'm retrieving the first row of entire data. So you will get the difference value. The difference value is multiplied by the random value between 0 and 1. Again, when I takes 1, it will give you the first row, and it will calculate the first parameter value. When I value become 2, and it will retrieve second row value, all other things are going to be the same, because the LL and then UL doesn't change, because we have given I. We have not given I because we have given 1. So whenever we are giving I, this value get changed each and every time, but other value doesn't change. So now I have calculated PV value. Now I want to display PV value. So you have to see this green color symbol. So I'll explain the next program. So I have to save this. I have saved this program in the file name PV underscore INIT. So in the folder Zoom Matlab, I'm just saving this file. It is saved. So now we can see the file name. This is drive, folder name, and file name, right? Now I want to execute the program, and this green button, this is actually running the program. You click this and it will ask you the number of samples, right? So yeah, I have given number of samples 5. I can able to get 5 different values of A, B, C, D within the lower limit and upper limit. So this is lower limit and this is upper limit. Okay, and see, because the gap is more, I'm giving format compact. So now you can see the what you call PV value. This is PV value. Now you can see the first column is between 10 and 14. Second column is between 20 and 30. Similarly, third and fourth value, right? So again, I'm displaying both LL and upper limit value so that you can see the entire value are within the limit. So with that, the first exercise is over. So in this exercise, we wrote a simple program for generating random value between lower and upper limit. The second exercise is the lower and upper limit is given. So you want to find out the objective value. So now clicking this, you can open a new window. In this new window, you can type what you call your data. So here I'm asking generate NS user input. That means I'm giving NS equal to input enter number of samples. Okay, I'm getting as input from the user. And then I want to define, or I want to assign the lower limit going to be 10, 20, 50, 33. And my upper limit going to be 14, 30, 70, and 66. Now I don't know how many variables are there. To knowing the how many variables, then I have to define the NV, number of variable, equal to size of LL comma 2, because 1 represent number of rows, 2 represent number of column. See, because 1, 2, 3, 4 column, that means 4 variables are there. So this line we are using to know number of variables present in the given lower limit. Okay, and now we know how many variables are there. So now we have to generate R1 random value NS comma NV, NS rows and NV columns. Now we have to calculate the parameter value. So for I equal to 1 to NS, the same formula which we have used in the exercise 1. PV of I comma colon. It indicates when I take the value of 1, so it defines the first parameter value, and already we know the LL, because the size of the LL going to be only one row, and we are retrieving entire column. Then R1, it is having NS by NV. We want to retrieve only the first value or ith row, and the UL, LL are constant. Only the based on changing RI value, the PV value get changed. Now we have calculated what is the parameter value. Now what we want to do is, we want to substitute these parameter value in this equation. We have to find out what is the objective value. See, A, the first column value, and B is second column value, and this is third column and fourth column. In PV, we have got 4 value. In PV, we have got 4 value. And this module, this entire code, we call it as a initialization module. So here we'll get Fanta color. This shows that we want to pre-allocate memory. For pre-allocating memory, we want to fill with zeros. That is zeros, NS, NV. So now you will not get any line. So it is clear, you will get green color. That means your coding is okay. And now we want to enter into evaluation module. That is nothing but, once the parameter values are known, these values are substituted in this equation, we can find out, so what is my objective value. So my objective value I comma 1, that is equivalent to, because I takes a value 1 to NS, I'm just typing all these value 11.43, 1.36. A represent in the parameter value, it is going to be first value, because we are generating value between 10 and 14. 10 and 14 represent A, this is B, and this is C, and this is D. So first value, it's going to be A value, and next value it is going to be B, and the third value going to be C, and then fourth value it's going to be D. These constant value, it is given in your problem. I am just typing this value. So with that, the calculation of objective value is over. See, because the size of PV is nothing but 4 column. Each column represent the value of the variable. Okay. So now the calculation of objective value is over. Now we want to display. See, again here we are getting, so OV might be growing inside the loop. We want to pre-allocate the memory. So that means we want to fill with zeros, right? So now what we want to do is OV equal to zeros, open bracket, NS comma 1, because the size of OV going to be only one column. So that's what I'm giving 1. So now pre-allocated memory is over. Now I want to display the answer. So I want to display both parameter and then objective value. This is what you call, already we have seen, combining the arrays, right? Now you can able to see the answer. So I want to save. So I'm saving this program as OV underscore evaluation, and they save the program. If you double click, this window will minimize or normalized. Now you click run button. So it's asking you enter number of sample. I'm giving 4. Now I'm maximizing this. So for 4 sample, so this is actually 1, 2, 3. This is PV value, and this is actually PV and then my objective. A value, B value, C value, D value, corresponding PV value, right? So now I want to improve the readability. I'm introducing a line, DISP, the parameter value of A, B, C, D and objective value. Just I want to display so that I come to know what the data is displayed on your command area. Okay. Now I'm using this. I'm typing a small line to improve readability. Now you execute the program. It is asking number of sample. I'm giving 6 sample. I'm double clicking. Now you can able to see, right? See, but you can able to see the previous data also, right? What you can do is in the program, you can use CLC clear screen as well as clear all, CLC clear screen. Okay, and then clear all means whatever the variable declared, I want to clear all the variable, right? This is for clear the screen, and the next line we added for clear all variables. Okay, now you run the program. Okay, now it is clear. Now you run the program. Sample 6. Now we can able to see there is no previous record. So only whatever I have given, that is visible. Again, unnecessarily I am having PV and later on PV and then OV. I don't want to display the other values. That means PV value. So what I can do is I can comment this line. So once this comment means this will not execute. Now I am running the program. Sample is 4. Now we can able to see only PV and then my objective value. A, B, C and D, and this is my objective value. So with that, the second exercise is over. The third exercise is I want to get some attendance percentage. Based on the attendance percentage, I want to find out the internal mark. I have opened a new file. In a new file, I am giving marks. I suppose to give attendance. Later on, I'll change it. Okay. Input, enter, marks. It's not marks. It's supposed to be attendance. Later on, I'll change it. Okay. Okay. Marks obtained by the student. Okay. I just maximize so that you can able to see the code. So before that, I want to introduce CLC and then clear all. And the next I want to get how many sample. Okay. So based on the given input data, I can find out how many samples are there. Okay. I don't want to get a separate input as number of samples. So now whatever the data I'm getting from marks, so the first row, that means the size will return number of rows and column. I want to get number of rows, right? That's why I have given 1 to know how many marks are given or entered. Okay. Now I'm using for loop for I equal to 1 to ns. I'm using if. Okay. That marks, I want to give this condition. Mark is less than or equal to 75. See, because I'm not giving mark because I going to be the first mark. Okay. When I take the value 1, it represents the first row, first column. I takes the value 2 means second row, first column. Okay. So the marks value less than or equal to 75 and marks. So this is actually less than or equal to 80. This I change into greater than or equal to 75. Because it should be greater than or equal to 75. This is less than or equal to 80. Okay. And then I'll put internal mark IM. I'll put the variable name IM. It will store the internal mark I comma 1 because it is going to have only one column, right? Number of rows is equivalent to ns. So if the mark or attendance is greater than or equal to 75 and less than 80, I am assigning 3. See, because it is going to be less than or equal to, right? Greater than or equal to 75 and less than or equal to 80. And otherwise, the mark is greater than 80 and less than or equal to 90. Less than or equal to 90. Okay. So marks, actually, I made a mistake. Here also, I have to make I comma 1. While running the program, you will get some error. Then after that, we'll make corrections. Okay. So I am I comma 1 equal to 4. And then next condition is If it is greater than 90, okay, then I am I comma 1 is equivalent to, it is 5. And else, suppose if you are giving marks less than 75, the internal mark is going to be 0. Put end and then display. So the marks, see, because here I have to change attendance, because this entire program based on attendance. So how much attendance you are getting, based on which your internal mark is assigned. Okay. So already I told you that here I made some mistake. I supposed to give marks I comma 1. Okay, I made wrongly. See, now actually I am changing enter marks, enter percentage of attendance. So if I am changing here, entire thing I want to change. So to avoid this, again I am correcting this ATT into my MARKX, because it is just like a variable. Okay. Here I am making percentage of attendance and then internal marks. Okay. To improve the readability, I have given a line. So display. So the marks MARKS and then space, then IM. So now I am saving this program. If I am running this program, I will not get the output, because here I have given marks. So I suppose to give marks I comma 1. Here also I have to give mark I comma 1, right? That is a mistake we committed. So this is for free allocating memory ns comma 1, because the internal mark going to have only one column. So you got green color. You save this. Okay, run the program. You will get error now. Yeah. So now I am entering the mark. That means attendance 50 and then enter and then 78 and then 94 and then 84 and then 76, 45. So now you have seen some error, because already I told you that here I have given marks. I supposed to give marks I comma 1. That is a mistake I have committed in the program. Now I just recorrect it. So here I have to recorrect, right? Marks open bracket I comma 1 close bracket. Here I have to change mark I comma 1 close bracket. Here also I have to change mark I comma 1 close bracket. Right? Now it is all right. Now you run the program. So I have to minimize the window. Yeah, it's asking attendance obtained by the student. I'm giving 93, 84, and then 76, 60, 98, 45. Now we can able to see the answer. So if it is 93, it covers greater than 90, you will get 5 mark. 84, this is between 81 90, you will get 4. 76, this is 75 to 80, you will get 3. And 60 less than 75, you will get 0. And similarly 45 less than 75, you will get 0. So with that, the third exercise over. And next is the fourth exercise. You have to normalize the VI value. So this is the VI value is given. So whenever you are writing any program, the comments of the program, if you are including, it is good. So I'm giving the percentage symbol. So this program used to normalize the given values, right? So this is comment of the line. In each and every program you have to give CLC, clear all, and VI. So I want to copy this value. I cannot copy directly from PowerPoint. I paste it in Excel, and again I copy it and paste it in our Matlab environment. Okay. Now I want to know how many datas are there. I'm using size function, size of VI, comma, I want to know how many rows. I'm giving 1, right? So to know about how many samples are there. Okay. And next is, so we want to find out what is the minimum value, what is the maximum value. I've given MMVI. Okay, that represent minimum value of VI, right? I'm using a function minimum. So I'm giving MMVI. This is to get minimum value of VI. And this is to get maximum value of VI. Now you got what is minimum value, maximum value. Now using for loop, we want to find out what is the normalized value of this VI. I am giving NVI. When I takes to 1, it represents the first row, first column. So this VI minus V minimum, that is minimum of VI, close the bracket, divided by V maximum minus V minimum. So MX of VI minus MM of VI, close the bracket, semicolon, and then end. So with that, the normalizing over. Pre-allocation memory is required. I am going to fill with 0. See here also I made one problem. See here I have given percentage here. I am supposed to give percentage here. While running the program, we will face some problem. Again we will correct it. So NVI equal to 0 NS comma 1, right? So display, I want to change into single quote. So whenever you are wrongly typing, you will get a red color line. It shows as some error in the syntax. So now I can change this value, single quote, VI and this normalized value. Okay. And then display. In the next line, I'm going to give VI and then NVI. VI and then NVI. Okay. Now I'm going to save the program. So nar underscore PV. I'm saving this program. I'm going to run the program. I'll face error. That already I told you. We'll face some error. Yeah, because the percentage symbol I have given wrongly, right? So I supposed to put percentage symbol before 2. That is a mistake we have committed. We'll correct it in the program. Yes, here we'll correct it. Now we'll run the program. We'll get the answer. Yes, now you got the result. Okay. See, because it is going to be maximum value, this is 1, and this is going to be minimum value because 0, because VI minus minimum, this is going to be minimum value, and this is also minimum value, you get 0, right? And next we'll write what you call, we want to check this VI value whether this vi value is between 10 and 20, you can leave as it is. If this is not between 10 and 20, and you have to use this if statement, you have to correct vi value. So if this vi is less than your lower limit of 10, then what you have to do is 2 times of your lower limit minus the current value. Similarly, if it is higher than your upper limit, 2 times of upper limit minus the current value, right? So what I want to do is I want to copy that value of vi, which I have given in the previous program. I have copied and I have pasted here. So I want to know what is the size. Vi comma 1 represent number of rows. Some mistake is there. I have committed a double open bracket, square bracket. I'll correct it now. See, it is giving the answer. Okay. See, here I've given double open bracket. I'm removing this. Yes. Now there is no red color line. Okay, fine. So now I know how many data are there, how many rows are there. I'm going to use for I equal to 1 to ns. I'm going to use if condition. If the vi of, okay, I comma 1, vi of I comma 1 is less than your vl, that is lower limit. They have given 10. I'm giving 10. Okay, if it is less than 10, then my vi value is equivalent to 2 times of 10 multiplied by the current value. So 2 multiplied by 10 minus the current value vi of I comma 1. And else my condition is, see, vi of I comma 1 greater than my upper limit 20. So I have to give vi of I comma 1 is equivalent to 2 times of upper limit, that is 2 into 20 minus vi value, 2 into 20 minus vi of I comma 1. Suppose these two conditions not satisfied, right? I want to have the same value. See, because I want to show the difference, the new value and the old value, what I want to do is I want to have n new value, this is also new value, and if these conditions not satisfied, the new value going to be the old value, because there may be value between 10 and 20. Okay, so if the value between 10 and 20, the old value we are assuming as the new value. Okay, that is the meaning of this. So I want to pre-allocate memory. It's going to be ns comma 1. Okay, fine. So I want to display both old value and new value. Okay, the old and new values of vi, display old value going to be vi, new value going to be nvi, dasp open bracket square bracket and then vi and then space nvi, close square bracket and close bracket, right? Now you can save this program, pv check, in the name of pv check. Okay, and then save this and run the program. Okay, you got the answer. See here, so this is old value, this is actually greater than 20, and new value you got 17.062, and this is actually less than 10, again new value is there, and this is between 10 and 20, no changes. This is also no change, this is also no change, this is also no change. This is less than 10, I want to change the value, it has been changed, and this is okay. This is higher than 20, so I want to change. This is lower, less than 10, I want to change it. So with that, the entire part is over.